Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you. Am I properly audible to all of you? Please let me know once. Yes guys, good evening all of you. Am I properly audible and visible to you? Please confirm once in the chat box. Hi Ashutosh, good evening Chandan. How are you all? Yes. Okay, thank you Chandan. Yes guys, quickly like the session and share with your friends in all the Telegram groups and WhatsApp groups so that the students, those who are preparing for GATE 2022 exam, they can also attend this class and get the benefit of this class. Okay. Yes, so this is the fourth class of this GATE Super 11 series and the subject today is operating system. Right, so I hope you have well prepared for this subject. Okay, and yes, I'm good too, Chandan, thank you. Yes, so I hope you have well prepared for the subject and today we are going to solve the 11 questions. So without waiting, let's start guys. So let me introduce myself. My name is Anshul Sharma. I have 1+ years of experience in GATE 2020. I have secured All India rank 294. I have cleared ISRO and NILET exam, mentored more than 1000 students as of now, and these are my area of expertise. Good evening Raman, good evening Tushar, good evening all of you. So those who want to connect with me, they can join this Telegram group. So this is the link. Okay, you will be getting the PDF of all my YouTube classes. If you have any doubt, you can ask your doubts there in the group also. If you need any guidance, then also you are most welcome. So you can connect with me through this Telegram group. This is the link. Okay, and after every class, I will be uploading the PDF. So without waiting, let's start. This is the first question on your screen. Yes, everyone. What should be the correct answer for this question number 1? And before starting guys, I would request to all of you to kindly like the session and also share with your friends as much as you can. Yes guys, good evening Tahir, good evening all of you. Yes, Nikhil Saram, in first year, can I crack GATE? How to prepare for GATE exam and which year I should prepare for it? You can start from second year. You can start from second year because now third year is also eligible. Okay. Good evening, Mukesh. Yes, guys, quickly solve this question. Which of the following statement or statements is or are true? So Raja is saying option A should be the correct answer. We'll see. Yes, everyone. Ashutosh is saying D should be the correct answer. Tahir is saying option C. So we are getting multiple answers now. Let's see who is correct and who is incorrect. Good evening, Roshni. Yes, guys. Option A. So most of the students are saying option A is the correct answer here. Well, let's see this. Let's see this question now. Question number 1. Which of the following statement or statements is or are true here? Statement 1 is, compared to kernel level threads, user level threads are fast to create. Yes, definitely it is true. It is true. Why it is true? Because there is no operating system intervention when we talk about user levels. When we create the user levels, we use the APIs, not the OS. OS involvement is not there. That's why it is fast for the creation as compared to the kernel level threads. So this statement is definitely true. Now what about statement 2? User level threads get support from kernel level for the thread creation. This is false. We use the APIs, right? So this is false. There is no support from kernel. Statement 2 is false. What about statement 3? Kernel level threads performing blocking system call may block the entire system. What do you think? Is it true or false? So we know this in case of user level threads, if one thread performs the blocking system, a block call, then in that case the entire process will become block. But in case of kernel level threads, all threads are independent. In user level threads, all threads are dependent. Kernel level threads, all threads are independent. Even if one thread performs the blocking, the entire process will not get blocked. This statement is false. This statement is false. Is it clear? Is it clear to all of you? So option C is the correct answer here. Option C is the correct answer here. Only statement 1 is true. I hope it is clear. I hope it is clear to all of you. No. Yes, all are independent. Yes, let's proceed and solve this second question. Question number 2. Yes, guys. Read the question carefully and then let me know your answer in the chat section. Guys, do like the session. It just motivates me, right? If you like the session, just you can mark your presence by liking the session. Okay, so that's why, Raja, read the question carefully. In the gate exam also, try to avoid silly mistakes. Yes, what should be the answer for this one? Maximum and minimum, how many page faults will occur respectively? Let's see how many of the students will answer this question correctly. Ashutosh is saying option B should be the correct one. Okay, we'll see. Anya is saying option C. Tahir is saying option B. Okay. Yes, guys, share the session also in all the groups so that we can have maximum students. Kaushalya is saying option B. Okay, most of the students are now saying option B should be the answer. Let's solve this question now. Consider a process with P frames all initially empty. The length of page reference string is Q. So one page reference string is given to you and the length is Q. And it contains R distinct page numbers. Let's say we are having something like this. Let's say 1, 2, 3, 4, 5, 6, 7. So I'm considering the maximum case. Okay. So here the value of Q is also 7. Here the value of R is also 7 because all are distinct. So for how many replacement, for any page replacement technique, maximum how many page faults will occur? Obviously for all the page request, there will be a page fault because all are distinct. Yes. So maximum will be Q. And what about a minimum? Let's say if you are getting something like this 1, 2, 3, 2, 4, 5, 5, 6. Let's say. Now in this case, what is the length? Q is again 8. Now Q is 8 here. But the value of R is distinct is 1, 2, 3, 4, 5, 6. So this is 6. In this case, minimum if we talk about the page faults will be 6. So B is the correct answer. This is your maximum and this is your minimum. Is it clear, everyone? So maximum page fault will be there when all are distinct, and minimum when few are distinct and few are, you can say, repeating again. So minimum will be R, maximum will be Q. I hope it is clear to all of you. Let's proceed to the next question, and that is based on this scheduling algorithm. So let's solve this question, all of you. I have taken all the concepts of operating system. At least one question is definitely there from every concept of operating system. Or we can say at least unit. Yes, what should be the answer? Solve this question. You have to use FCFS disk scheduling algorithm to service all these IO requests. Very simple question. You can solve this question within maximum, you can say 2 minutes. If you are quick enough, you can solve within 1 minute as well. Is it fine now? Yes, is it fine now, all of you? Yeah, now it is working fine. Yes, yes. Please refresh from your side. I think now it is fine. Now it is working fine. Okay, so we are getting the answers. 146 into 6, okay. 876, 816. Let's see who is correct. Yes, everyone. Quickly answer this. What should be the answer? Let's solve this question now. A disk request come to a disk driver for cylinders 10. This is the request, right? And in that order at a time when the disk drive is reading from cylinder 20. That means the current position is 20th cylinder. The seek time is 6 milliseconds per cylinder. The total seek time if the disk arm scheduling algorithm is FCFS. So here we are currently present at 20th cylinder, right? Then as it is FCFS, so whatever is the order of request, in that order only we are going to service it. So from there I can go to 10, right? Then 22, then 20 again, then 2, right? Then 2, and then after that it is 40, then after that it is 6, and then it is 38, right? So what is the difference here? The difference is 10 plus, here the difference is of 12, 22 minus 10, that is 12. Here the difference is of 2, then the difference is 18 because 20 minus 2 is 18, plus 40 minus 2, that is going to be 38, then 40 minus 6, it is 34, and then it is 32. So if you add this, what you are getting? You will be getting 146, right? 146. These many cylinders you have to cross to service all these requests, and servicing one cylinder requires 6 milliseconds. That means the seek time is given to us. So total seek time will be just multiply by 6 milliseconds. So if you solve this, what do you get? 24, 7, 2, and this is 8. So 876 milliseconds is the correct answer. I hope all of you are getting the same answer. If yes, then it's good. And let's proceed to the next question, which is a theoretical question, MCQ. Yes, what should be the answer? Very good, all of you, those who are answering the questions correctly. Yes, let me know the answer for this question. Question number 4. Nisha is saying option A should be the correct answer. Okay. Raja is saying option C. Anya is saying option C. AB de Villiers, option A. AC. This is MCQ. MCQ, not MSQ. Nayak. Okay, so C and A, that is the confusion. Let's see which is correct. If file system is large and if it is to be accessed randomly, then which of the following allocation strategies should be best to use in a system? So let me tell you one thing. When you have contiguous allocation, so we use this one when the file size is small, okay, and when it is a sequential access. When we need sequential access, then only we use it. What about linked allocation? We use it when the file size is large but it is a sequential access, okay, and we use indexed allocation when the file size is large and random access we need. So according to this, which is the correct answer? Option C is the correct answer. Okay, let's proceed, and question number 5. Quickly solve this, all of you. Yes guys, yes guys, focus on the question. What should be the answer? Yes, numerical answer type question. Anyone getting the answer? Question number 5. Nisha is saying 11, Raja 11. Yes, Tushar, question number 4 repeat कर दीजिए. Question number 4 में it is talking about if the file size is large and we need random access, so definitely indexed allocation we need. Okay, let's solve this question. A system has 6 processes sharing n resources where 4 processes need at most 3 resources and other 2 processes need at most 2 resources. If the system is deadlock free, the minimum value of n, that means how many resources you need. So 4 processes are using at most 3 resources, so just allocate 1 resource less than the maximum demand. Maximum demand or peak demand is 3 for these 4 processes, just allocate 1 less, that means 2. Plus for the remaining 2 processes, the maximum demand is 2, so just allocate 1 resource less than the peak demand, so it is 1. Now if you allocate these many resources, then the system is in deadlock. Just allocate 1 more resource and now the system will be free of deadlock. 4 to 8, 8 plus 2, that is 10, 10 plus 1, that is 11. So minimum, if you want your system to be deadlock free, minimum 11 resources you need. Answer is 11. Yes guys, that is correct. 11 is correct. 11 is correct. And now let's solve this question. Question number 6 based on synchronization. I hope the question is visible to all of you, right? Now it will be visible. Carefully read the question and then only let me know your answer, okay? Yes guys, do like the session if you haven't liked it yet, and also share with your friends. Tomorrow we are going to have another session that is on compiler design. So 11 questions again on compiler design. And then after that you will be having other subjects that will be taken by other faculties, okay? Yes, so we are getting the answers now. Nisha is saying D, Tahir D, Ashutosh D, Raja D, Tushar D, AB de Villiers D, Anya D, Jetlob D. Okay, let's solve this question now. Consider the following 3 processes with the semaphore variables A, B and C to print output this output. Which of the following could be the initial values of semaphores when 3 processes executed concurrently? So there are 3 processes, P1, P2 and P3, and I want to print GAT, GAT and so on. So first of all you need to see, always we have to start with G. So process P1 is printing G, right? That means the execution has to start from P1 only. To start the execution from P1, as it is doing P of C, that means it is performing wait operation on C. So the value of C has to be 1. Value of C has to be 1, right? And we don't want other processes to start. We don't want other process to start. So we want the value of initial value of A as 0 and initial value of B as 0, so that only process P1 can first start. Getting the point? So C has to be equal to 1, then A is equal to 0, B is equal to 0, right? Now if you see here, option D is matching with this. So if C is 1, it will print G, then it will signal the value of B. If it signals the value of B, now it can print A, so GA, then it will signal the value of A, it can print T. So GAT, and then it will again signal the value of C, so it is going to print GAT, GAT and so on. Clear? Option D is the correct answer. Very good, all of you, those who have answered this correctly. Let's solve this question number 7. That is based on CPU scheduling algorithm. Take your time and try to find out the correct answer, okay, in just one try. Numerical answer type question, so don't commit any kind of calculation mistake here, because in gate you will never get, more than one chance. Maybe you will get a few questions to just revisit, but not for all. So it's better to perform the calculation carefully so that you can avoid these mistakes. Have to calculate the average waiting time. Okay, Raja is getting 6.4 as the answer. Anya is getting A. Mukesh is getting 5.6. Okay. And it was obvious that in numerical answer type question, we will be getting different answers for sure. Even if the question is too simple, still we will be getting multiple answers. You can see we are getting different answers. 6.4, 8, 5.6, 6.4, now 5.6. Okay, so now students are getting only one answer, 5.6. So let's solve this question. Consider the following processes with their corresponding arrival and running times in milliseconds. So 5 processes are given here, right? What will be the average waiting time in millisecond of the processes under FCFS CPU scheduling algorithm? So let's solve it here. If we talk about FCFS, the process which arrives first in the ready queue, we are going to schedule it first. So at 0 units of time, you can see P1 process has arrived first. So we are going to schedule till its completion, because FCFS is non-preemptive CPU scheduling algorithm. 0 plus 6, it is going to be 6. Then at 6, after that P3 arrived, so we are going to schedule P3. So 6 plus 2, this is gone, 0. 6 plus 2, it is 8, this is also gone. Then you have this P2 process, 8 plus 6, it is 14, 0. P2 is also done. And then we have this P4, and then we have this P5, this is 17, and this is going to be 21. So what is completion time? You can find then turnaround time and the waiting time. Completion time of a P1, it is 6. For P2, it is 14. For P3, it is 8. For P4, it is 17. For P5, it is 21. Turnaround time, completion time minus arrival time. So this is 6. This is 11, 7, 11, and here it is 14. Clear? Waiting time, turnaround time minus initial burst time, 6 minus 6, it is 0. 11 minus 6, it is 5. 7 minus 2, it is 5. 11 minus 3, it is 8. 14 minus 4, it is 10. If you add this 10, 10, 20, 28 divided by 5, what do you get? You will be getting 5.6 millisecond as your average waiting time. This is the final answer. So I hope all of you are getting the same answer. Yes, that's good. Let's solve this question now. Question number 8. Yes, guys. Solve this question and let me know what should be the answer. Yes, what should be the answer for question number 8? And I was expecting this from all of you or from most of you to commit this mistake. You haven't read the question correctly. Try again. Read the question once again. See, in the GATE exam, don't pre-assume anything. Whatever is given in the question, accordingly you have to solve it. Okay? Don't pre-assume anything, otherwise you will be answering most of the questions incorrectly. Read the question again. Read the question again. That's why I included this question, because it is not a difficult question, but yes, we don't read the question. This indicates that if we are solving this question incorrectly, we don't read the question carefully. Okay, so you will think, okay, it is so easy question that we can solve within seconds, and then only you will commit the mistake. Clear? Still many of the students are getting incorrect answer. I don't know why. I don't know why. What is the reason? अरे भाई क्या हो गया है? Giving you 30 seconds to all of you again. Read it and again try to solve it. Few students are getting the correct answer. I'm telling you this. Few students are getting the correct answer, but most of the students are still saying incorrect. Let's see now. Let's solve this question. Let P and V be semaphore operations. Okay, that is fine, but it is explicitly mentioned in the question. Assume P represents signal operation. In standard we have P as wait operation, but here it is explicitly mentioned in the question to assume P as signal operation and V as a wait operation. Let S be the counting semaphore variable. S is equal to 1 initially. If the following operations performed, how many blocked processes are present in the system at the end? Remember, this P indicates signal, not wait, and V represents wait operation. Initial value is 1. 5P, that means 5 signal operations. So plus 5 minus 7 plus 10 minus 14 plus 25 minus 32. Now you solve this question. So what do you get? This is 6, 16, 16 plus 25. How much? 16 plus 25, 11, 41. Minus 7, 14, 21, 32, 21. 53. 53. Minus 12 will be the answer. That means 12 processes. Now it is, you need to understand here, if counting semaphore, if the value of counting semaphore is negative, that indicates how many processes are still blocked in the system. So it is minus 12, that means 12 processes are blocked in the system. Here it should be 12. Here it should be 12 because it is asking for the number of processes, right? But the final value of the counting semaphore will be minus 12. That means 12 processes are blocked. Is it clear? Is it clear to all of you? So answer should be 12, right? Why? Because it is asking how many blocked processes are there. So that number should be positive. Clear? But if it asks for the final value, it should be minus 12. So as per the question, D is the answer. D should be the answer. Wrong option, no. Otherwise, you will be getting like numerical answer type question. Still, I have given you the options, but you got the concept. The point is read the question carefully, even if it is too easy. Okay, pay attention to the question and then solve. Yes, question number 9. Solve it. Tell me the answer. In GATE exam also, you might have seen the previous year question. In some questions they change the definition completely, right? So you have to be dumb, right? Just whatever is given in the question, just read it and do it. Simple. Okay, we are getting the answers now. Option A, De Villiers is saying option A, Ashutosh option A, Noob option A, Chandan option A, Nisha option B. Okay, let's see this now. In context of critical section problem solution, match the following items correctly. Software approach, we know this. Peterson algorithm is software based. Hardware approach, test and set log, that is hardware approach. So first to D, second to A. This is for sure, right? Correct. Then OS approach is semaphores and compiler approach, because it is based, monitors is based on programming, that is a construct. So that is compiler approach. Monitors is compiler approach. So we can say third one would be what? Third one is a B and fourth one is C. So this should be the correct answer. DABC, option B is the correct answer for this. Hi Ankit. Is it clear, everyone? Let's solve this second last question of today's class, question number 10. Again, numerical answer type question. Yes, guys, solve this question. Yes, solve it, all of you. You have to solve numerical answer type question like you have only one chance to mark the answer. Okay, think like you are never going to get the chance again in the exam to just revisit that question. So that much accuracy is required in numerical answer type question. Okay, we are getting different answers now again. 90 second, 90 second and 150 nanoseconds. Anyone else getting the answer for this question? Yes, guys. Anyone else getting the answer? Okay, 90 again. Let's solve this question now. Compute effective address time in nanoseconds when TLB used in two-level paging with following parameters. So TLB access time is given to us, memory access time is given to us, hit ratio access time is given to us. What is the formula? Formula is, if it is a hit in TLB, so TLB access time is required. So TLB, we perform the address translation and then we are going to access the main memory. But if it is a miss, in that case, first you have wasted some time for TLB access, so T will be there, plus two-level paging. So let's say K, this indicates K level paging, K multiply the main memory access time. Why? Because page table is also stored in the main memory. After performing the translation, you will be moving to what? Final the content, to access that content in the main memory. So this is going to be the formula: 0.8 20 plus 50 plus 0.2 20 plus K level, K is 2 here, So 2, or you can directly write 3 into m also, but let's write 2 into m, that is 50 plus 50. So if you solve this, this is 70, so you will be getting a 56 here, plus this is 150, 170, 0.2 into 170, you will be getting 34. So that will be equal to 10 and 90 nanoseconds will be the answer. Is it clear to all of you? If you have any doubt, please ask. Any doubt, anyone? 90 will be the correct answer. Yes, Tahir, क्या हो गया? 90 will be the correct answer, final answer. Let's solve this last question based on a round robin CPU scheduling algorithm. Question number 11. Last question of today's class. Solve it. Only one chance, numerical answer type question. Okay. Let's see how many of you will answer this question correctly. And guys, do share this session with all your friends, those who are preparing for GATE exam, GATE 2022 or maybe GATE 2023, so that they can do well. And tomorrow, same timing, 8 p.m., we are going to have 11 questions on compiler design. So before coming to that class, do revise that subject, okay? Yes, average turnaround time you have to calculate. Let's see how many of you will answer this one correctly. Okay. Raja is getting 4.5 as the answer. Let's see whether you are correct or not. The most of the students in the GATE exam, not most, but I would say yes, 5 to 10% students, they don't do well in the GATE exam even after having the knowledge, because they commit silly mistakes. So many silly mistakes they commit, and then they regret after the exam. So even after having the knowledge, still they are not answering the question, making silly mistake. That is not acceptable, right? It should not be acceptable to you also, right? So I always feel that if you have prepared well, if you have done so much hard work for this exam, so you should not underachieve. Always try to achieve as per your capability. If you are underachieving, that is the worst thing you can have, right, in an exam. So just try to avoid the silly mistakes, and let's solve this question. Consider the following processes with the CPU burst time in millisecond. Assume all processes arrive at time is equal to 0 millisecond. If the processes uses round robin scheduling with time quantum is equal to 1 millisecond, then what is the average turnaround time of the processes? So let's solve this question here. So we are going to maintain the queue, because in round robin we use queue, and here we are going to make the chart for the scheduling purpose, right? So here, as you know in the question, all the processes have arrived at 0. So we are going to follow the order just as it is given. So we are going to have P1, then P2, then P3, then P4, and then P5. So at 0 units of time, we can schedule P1, but for 1 unit of time. Why? Because time quantum given is 1. Clear? Time quantum given is 1. So 1 unit of time. And here I can make it 8. Then I will be scheduling P2. We can just dequeue it and we can enqueue it again. Right? So P2, 1 plus 1, it is 2. Here it is going to be 1. And then it is going to be P3, 3. Here it is going to be 0. P3 has completed its execution. Clear? We can write P2 here and P3 is gone. Then it is P4. So 3 plus 1, that is 4. Here we can make it 1. Clear? Now we can enqueue it again here. Then P5, 4 plus 1, it is 5. We can make it 3. Now here it is P5. Then it is P1 again, 6. And here we can make it 7. So P1 we can write here. It is P2, then 6 plus 1, it is 7. It is done, 0. P2 has completed its execution. So P2 is gone. Now we have P4, 7 plus 1, it is 8. P4 has also completed its execution. Clear? P4 is also gone. Then we have P5, 8 plus 1, it is 9. And here it is 2, right? So we can just enqueue it again, P5. Then we have this P1, 9 plus 1, it is 10. So here we can make it 6. P1 here. And then we have this P5, 10 plus 1, it is 11. Here we can make it 1. P5 is here now. Then we have this P1, this is 12. We can make it 5. And finally we have this P5, that is 13. We can make it 0. P5 has completed its execution. And finally we have P1. So 13 plus 5, that is 18. Now let's write the completion time, the turnaround time, and we have to find the average turnaround time, right? So completion time, you have to, whenever you are using a preemptive CPU scheduling algorithm, always scan from the right hand side. Always scan from the right hand side. Okay, just to avoid the mistake. Completion time of P1, it is 18. Completion time of P2, it is 7. Completion time of P3, where it is 3. Completion time of P4, it is 8. Completion time of P5, it is 13. Turnaround time, completion time minus arrival time. Arrival time is 0 for all the processes. So it is going to be same. 7, 3, 8, 13. If you add this, what do you get? They said 10, 28, 28 plus 21. 49. So 49 and 49 divided by how many processes? 5. What do you get? 5, 9 is 45. 9.8. So 5, 8 is 40, and we will be getting 9.8 milliseconds is the unit, right? Milliseconds. That is the answer. Average turnaround time. Is it clear to all of you? Any doubt? Any doubt? Anyone? Okay, so guys, try to avoid silly mistakes as much as you can. Okay, and these are not difficult questions. Similarly, in the GATE exam, majority of the questions are easy to moderate level only. Still we commit mistakes and we don't achieve whatever we deserve, right? So try to avoid your silly mistakes, and then you can focus on the difficult questions, right? So that's it from today's class, and this is the link. If you want to get this PDF of this YouTube classes or all my YouTube classes, you can join this Telegram group. The link is there, you can see it, right? You can take the screenshot as well, and you will be getting the PDF, doubt clearances, as well as if you need any guidance, then also you are most welcome. So thank you all of you for joining this class. We'll see you tomorrow, same timing, 8 p.m. with another session on compiler design, and 11 questions will be there. So I hope you have enjoyed this session. We'll see you tomorrow. Take care everyone. Good night and bye-bye. Thank you all. Thank you so much. Good night. Bye. Thank you.